Hey everybody, this is Larry. This is day 26 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. I'm very tired today, so hopefully this one will be pretty okay. I guess I say that a lot, but I definitely for workout this week I intentionally scheduled a 15-mile run. It took me about a little bit less than 3 hours, so it was not a fast run, but it was just so tiring after 2 days of back-to-back like 10 miles hard effort. So my legs and my mind and everything is just very tired, very dead, and all these things. So doing the best I can. But yeah, so let's take a look at today's problem. I'm a little bit tired. Probably won't do an extra bonus question, but we'll take a look. 1334. Find the city of the smallest number of neighbors at a threshold distance. Okay, so you have n cities. Given that array edges where from to rate is bidirectional. Okay, that's actually that's the thing that I always look for. Okay, and distant threshold. That's just like that's not an edge. I think it's not super clear, but okay. Return the city of the smallest number of cities that are reachable through some path and cruise distance is at most distant threshold. If there are multiple such cities, return the city of the greatest number. Okay. Okay, yeah, so I mean, there are a couple of ways you can think about it. The first thing I want to do is look at the constraints because for graph problems, it really matters. And okay, just as I suspected, n is 100 is going to be good. The reason why I suspected n is going to be 100 is because, there are really a couple of ways to do it. My first initial thought, actually, to be honest, is going to be Dijkstra from each node. Of course, that's going to be, instead of n, let's say v for number of vertices and y for number of edges, then it's going to be v log y-ish, right? Yeah, and as a result, then it's just going to be v squared log y, which can be expensive because, but it also depends, right? And then the other thing that you can do, of course, given that n is only 100 or v is equal to 100, then you can also use Freud-Warsaw, right? Which is, now we're going from greedy to dynamic programming. So, not a bad thing, for sure. And yeah, let's just and it's easy to write, so I'm usually gonna write it that way. If I get a chance, so let's take a look. So we have return the smallest number of cities, or city with the smallest number of cities that are reachable. Okay, yeah. So maybe I'll have something like d is equal to say infinity times n for this is of course just to set up a distant matrix, and very often sometimes I forget about this, and sometimes it matters, sometimes it doesn't, depending on if you're trying to do some kind of closure or something. But here, I can just set itself to 0, and then it's just about parsing the edges. So then you have u, w in edges. So you have d of, is it 0 to negative? Yeah, okay, 0 index is equal to w. Sometimes they trick you this way, which is kind of awkward. But okay, they're all distinct. Even though they're bidirectional, so I guess technically speaking, why they call from to if they're bidirectional? I think that's the part that is a little bit confusing, but I guess in examples it doesn't, so I guess that's fine. For now, we'll trust this. Technically speaking, they did not really make it so that, I guess they did kind of in this way, but it's not explicit that all pairs are distinct. Oh, okay, maybe I take it back. Sorry, because of this constraint along with this constraint means that it should be distinct in pairs, and like in reverse. Though it's still very awkward to say call it from and to, but I digress. It's fine. Yeah, and then now it's just dynamic programming, right? D of ij is equal to min of d of ij, or d of I to k plus d of k to j, right? And then that's pretty much it. I mean, maybe you could do some allowances with distance threshold even here, but I don't find it that interesting. So we can just do like, you know, wait, what do we want to do again? City of the smallest number and the city of the greatest city. Okay, fine. So then here maybe we have best city is equal to, I don't know, none, doesn't really matter. And smallest number of cities are reachable. So reachable, best reachable is going to be, say, infinity. So any number is right, and then that should be good enough. And then here we go, reachable is equal to 0. And then we just count it out, right? If d sub I of j is less than or equal to distant threshold, then reachable we increment. And then if reachable is equal to, or if it's less than or equal to, then best city is equal to I, and best reachable is going to be reachable, right? And then that's it. Yeah. Can't click on the button for some reason. Yeah, let's give it a quick submit. Hopefully this is good and it is fast enough. One really quick note, I guess sometimes I just do it so quickly that I forget I do it. The reason why this is smaller than or equal to is that, remember that the tiebreaker for the second one is that the city of the greatest number, right? And because we do this in sorted order from smaller to larger, so if they're tied, then this number is always going to be bigger than the previous number, so that's why. Very minor thing. And this is just standard dice drill, so I'm not going to go over it. Oh, sorry, my bad. I was talking about dice drill all the time, but this is Floyd Warshaw, obviously, because I mean we talked about this, so it's not like, oh, I don't think I've been saying a dice drill the entire. If I've confused it the entire time, I don't think so, but if I did, that's my fault. But yeah, definitely check that out. And did I spell this right? Is it Floyd Warshaw? No, it's Floyd Warshaw. Okay, yeah. Definitely check that out. It's a very cool. I mean, I'm sure there are videos of cool diagrams on it. It's pretty. Yeah, it's an interesting one. Of course, this gets dominated by this part, which is n cube, which, you know, for a complete graph is pretty efficient. Just because of the low constant. If you and you know, I think yesterday or maybe the day before, I don't remember. Was it? Oh yeah. The day before I talked very briefly about intro sort, introspective sort, where you split things up depending on the constraints. Here you could kind of do the same if you really want to, which is that if there are a lot of edges, Floyd Warshaw is going to be close to optimal, just because, well, I mean, you know, just because the constants are very low, right? You could see the entire thing here. Where dice drill is going to do better if you have fewer edges, because again we have v squared log d, right? With a higher constant, just because, you know, you have to deal with cubes and all these, or heaps and all these things. But yeah, anyway, and in theory, if you really want to, you could do some intro sort idea of breaking it up, but I'm too tired. I can't even keep my eyes open again, so just like yesterday, gonna grind it out. But that's all I have with this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, good mental health. I'll see y'all later and take care. Bye bye.